All right, so today we will study DHCP snooping attack and ARP attacks, right? We look at, we already have learned about DHCP and now we will also learn about ARP protocol. Okay, so DHCP we have seen that one kind of attack which studied in last class, which is DHCP starvation attack, and today we look at DHCP snooping, spoofing attack. Okay, all right. So this is the one which studied in last class. So we know a DHCP provide, we do need DHCP protocol. When you go to a new place, a new city or somewhere, then you need corresponding IP address. Okay. Okay, your machine needs IP address. So you can communicate to the world outside because IP address gives you identity. Okay, and all what also you need is how to reach out to gateway router such that you can send your message internally over Ethernet, etc., to that gateway router, from where there your packets can go out. Okay, so all right, and at the same time, you when you want to Google something or you want to resolve a URL that you have, your machine says www dot, for example, IIT Guwahati at ac.in, but this URL is not an IP address. So this corresponding to URL, there is an IP address, right? So that IP address mapping, URL to IP address mapping, is done by domain name server. So then DHCP message also, DHCP message that you will receive when you boot up your laptop, when you want to connect your machine at new place, you also need what is the DHCP server in the net. Okay, so and you get IP address of, what do you get as the DHCP response? You ask for DHCP parameters because I am new to the network, please send me. You get IP address. Oh, I'm sorry, what's happening? Wow, IP address. You also get gateway router, which is connected to external world in your local area network, and also you need, what do you need? Third thing, domain name server's IP address. So gateway routers, this is IP address. Okay, all right. So these three things you need. Okay, now the protocol for that we have seen uses broadcast. So anybody on the net can see that and anybody can respond. Okay, and as a result of that, a lot of manipulations can happen. First thing is that denial of service attack can be done by anybody because number of IP addresses are all limited that's available to DHCP server. Okay, so what this guy can request as many as possible IP addresses, right, by creating new MAC addresses and sending DHCP requests. Okay, and as a result that this guy will respond, because it will not know that it's coming from the same person. It will know is that it's coming from different MAC addresses. So all this guy will use will get all the IP addresses that are available here, entire scope, and as a result of that, a third person wants now, you know, somebody connects a fresh, wants IP address, it will make DHCP request, then it will not get any because all IP address etc. have been consumed by this gobbler. Okay, so this is very simple attack. So this animation is here. This guy sends the request or discovery request for size of scope, means all possible IP address it wants. So it will continuously change the MAC address and keep sending requests. DHCP server will respond or give an offer, and this attacker will then, offer will come. Okay, these are set of parameters, and the attacker will say, okay, give me all, right. So it requests all offers, and this guy will grant it. Okay, and as a result of that, uh, this guy will get all IP addresses, and all other new guys who join in later will get nothing. Okay, now there's a countermeasure is that restrict the number of MAC addresses that can request to just few, right? Means that this guy can get maximum 2 or 3, can do 2 or 3 DHCP requests. Okay, so this provision can be done. So it means that now switch has got to make little more intelligent. Okay, all right. Okay, because you cannot make it only one, because on this switch there's a possibility that not only one machine but there are a number of machines are connected, because there can be another switch here. So you will have to restrict it to certain number of DHCP requests that can come on a port. All right, so let's now look at, so what you studied was starvation attack. Okay, it means that you starve others from getting DHCP parameters. Any question? No? Are you able to understand it? Okay. Either you are able to understand fully or nothing. So you need to answer. Okay. Now another attack is DHCP spoofing attack. Okay, all right. What can malicious person, rogue element can do apart from grabbing all IP addresses? What can it do? Same tricks we will see at multiple layers, right? Now, because basic thing is that all the protocols in internet, almost all, are distributed algorithms, basically based on distributed concept. Okay, and they are based on trust. Okay, internet, so two entities are running same protocol stack at both end. Stack may be made by different companies, but it has got to have similar, almost same state machine. Okay, and there's the assumption that that other party will be as honest as the first party, but attackers are attackers, right? They don't conform to all these laws of internet. So what can it do? Any thought comes? What that, see, you have to develop security mindset. Okay, some kind of how criminals think, or how this rogue element will think. Just think about it. What can it do? What can this person do now? Anyone? Look, one weakness we know that this guy, anybody may be requesting for something. Client may be requesting for DHCP parameters, right? This request is broadcasted, right? Because this client doesn't know where the DHCP server is. DHCP server is here, so it will go to everyone. Okay. So if it goes to everyone, so if this guy also receives it, then how can this guy manipulate it? It can create its own DHCP. It can act as a DHCP server. or it can connect a DHCP server to itself. Okay, and then send spurious DHCP message, DHCP response with fake IP address or some IP address. This IP address will be used by the client then, right? And then fake IP address of domain name server and fake IP address of gateway router. Now these three things it can set. Now what all he will do or she will do to do some attack? I'm asking you guys. Nothing comes to your mind, or are you sleeping? Hello?
Sir, I don't
Can
get
generate a
that.
fake request and ask for credentials like password, etc.
No, don't worry about password here. It's nothing about password. Now he has to manipulate along these things, right?
Yes, sir.
IP address, of course, he can assign IP address. First thing is IP address. This guy will assume, client will assume. So this IP address he can assign fake, non-existent IP address. Okay, possibly some IP address will give and it has no meaning. Okay, through which the response cannot come. That's one possibility. Second possibility is that domain name server. If he gives domain name server IP address as fake domain name server, which he has created somewhere, okay, maybe because he is a criminal and he will also have a website which will act as a fake domain name server. It can give name server or ROG domain name servers will act then. So when it says this client requests give me IP address of google.com, okay, instead of giving IP address of google.com, it can give IP address of another malicious website, say malicious.com, something like that, some website that has created. So it's an IP address. So now all the requests, now client will send the request to this malicious website. That's the second way of doing, right? What is the third thing? Gateway router. Now what is the concept of gateway router, right? In any cloud, okay, any local area network like your, there are only few routers through which any machine can communicate to outside world, right? Which is connected to ISP and so on. So it's a gateway router, right? So when when a machine is sending a message, it will have what it will do. It will have IP address of this. It has to send message through this gateway router, right? So it should know the IP address of this gateway router. Okay, and then of course it has to send it over Ethernet packet. So it has to also know Ethernet address of this gateway router. So what way the manipulation can happen now? Now let's not worry about Ethernet part. Now if this attacker supplies wrong gateway router address or malicious, there may be it may have some IP address corresponding to a ROG machine or its own machine, right? So it will advise this machine, his own machine, so IP address as gateway router's IP address. So what will happen? Okay, so now the client will send any message to outside world to this one, and assuming that it will go outside to external world. But now this guy can read all the messages that are going through client. So it can do, in some sense, man in the middle attack. Okay, so these are the two possibilities, right? Okay, so what happens that this new client requests this DHCP discover, or she wants to know what is my IP address, gateway, router's address, etc. And this genuine server will respond. This is correct server, or a true server. But at the same time, attacker server can also respond, and it will race it. Basically it will try to respond it fast with domain name server and the gateway router. So this he can provide wrong data or malicious data here, right? All right. So same thing is depicted here. So attacker connects to DHCP server. This is attacker. Okay, client request for DHCP parameter, like by sending DHCP discovery message. This message goes everywhere. Now DHCP server responds. The DHCP server receives it, and also this rogue element receives it, or criminal receives it, right? And then now this guy DHCP server responds, and also rogue DHCP server responds, and both reach to DHCP client. And if the wrong response is accepted by DHCP client, it means that now it will have IP address, gateway router IP address, and domain name server. All these parameters wrong, and these can be manipulated. Okay, that's the message, right? Okay, all right. So this is how it is. What are the countermeasures? Countermeasure is that you will have to define, each switch should know what are the trusted port. Statically, this has to happen right in the beginning. Okay, what are trusted port and what are non-trusted port? So these are the ports of a switch, right? So it will know that this is trusted port because there's some problem in my new iPad. So I need to figure out what's the problem. Okay, so this right in the beginning, somebody has connected DHCP server to this port. So this port is trusted port. Okay, now from this we can conclude this is non-trusted port. Okay, or untrusted port. Okay, what we show is as U, untrusted port. Now from this one we can further conclude this is going to be trusted port. Okay, and this is going to be trusted port, and something that's coming from bottom is untrusted port. So if the message comes from untrusted port, then simply discard it. That's the countermeasure. Because right in the beginning we know DHCP server is connected somewhere, okay, to a particular port. From this we can simply conclude that the message is coming in a particular port, then it's a trusted port. All right. So when a switch receives DHCP response, this switch receives this response on this particular port, it will simply discard. Now again, it means that now these switches should be intelligent, should have some software which will do this task. Okay, all right, any question? Okay. Wow. Just a minute, this is gone. Some problem, I don't know what's the problem, but okay. Give me a minute. No problem. Let me just no, somehow it's not working. Anyway, I will just open it up in different. Give me a minute. I will airdrop it again. Wow. Okay, I'll just open with different keypad keynote. So I hope it works. Just give me a minute. Okay. All right. So where are we? We are here. Okay. All right. Oh, I'm sorry. This is a different one I have opened up. Sorry. I don't know. There's some problem in my machine. Give me a minute. Okay. All right. There may be some animation problem because I have opened this in Keynote rather than PPT. All right. So, all right. So we'll discuss all this, right? Okay. Okay. All right. So now let's look at next protocol, which is called ARP. Why do you need ARP? Okay. Are you able to see the PPT?
Yes, sir.
Okay. So why do you need ARP? Address resolution protocol. What is anyone has thought about it?
So we can securely connect to the authenticated address, I guess.
No. Okay, so now we are into interplay between layer 2 and layer 3, right? So what DSC server has given back? Opa, there's something wrong. Wow. Totally messed up. Just a minute. Give me a minute. I will read. Something wrong with my iPad rather than. software. Give me a minute. I will get it on. Okay, let's see. I hope it doesn't trouble again. Okay, this is where we are. So why do you need ARP? Wow. Please help me. If what could be the problem with software? If I do it from this side, it's okay. If I touch it the bottom, it okay. Why do we need ARP? See, we are in the local network, right? LAN. DHCP has given us what? DHCP has given us IP address of the machine which is requesting, then gateway router IP address and domain name server's IP address. These are the minimum three things we have got. Now we have to communicate with, say, domain name server. Okay, and we are in the LAN environment, right? And one of these is connected to gateway router. So now we have to, and there is a domain name server inside. Let's assume domain name server inside. Okay, then how do I, if I want to know, I know I want to know google.com's IP address. So I will send a message. This is my machine. I will send a message domain name server to give me IP address of google.com. But how do I reach? I know it's IP address. I know this guy's IP address. But I don't know its Ethernet address. And within a LAN, I need to use only Ethernet address, right? So now I need to advertise as a client that please, I know IP address of this IP address and please respond with your Ethernet address. Once I know Ethernet address, then I can wrap up my message, whatever my message query is, and then send it over this destination IP address of domain name server, right? So this is to convert, or basically to know Ethernet address corresponding to IP address, we use ARP protocol. Okay, so it basically sits little above layer 2, and there are other protocol ICMP and RARP. So we'll now look at only at ARP. Okay. Okay. So the question is that how do a client reach domain name server which is inside local area network, because one knows only its IP address but doesn't know Ethernet address. Okay. So now this is a picture which you should look carefully. So DHCP, this is the host or client, and it has learned from DHCP that IP address is this one. Net mask, of course, is subnet we create, so just don't worry about it. Domain name server IP address is this, router address this. Now it wants to reach domain name server, this domain name server. But over Ethernet, now here we have shown thick Ethernet, but it's a switched Ethernet, doesn't matter. It has to send the Ethernet frame, right? And in that, it will have its query, and then he has to put destination Ethernet address, the destination address or Ethernet, right? Okay. So, all right. So now the question is that how does it know? So there's a protocol called ARP. So this is a source. It knows its IP address because this IP address got from DHCP. Okay. Okay. And then, okay. This is a destination IP address that it has come to know from DHCP response. but it cannot use this because it has to go over Ethernet, or Ethernet knows only hardware address, right, or layer 2 address or Ethernet address, right? Okay, so now it has to send this message, a message that please let me know IP address, and this machine will respond back. Okay, so as corresponding the IP address, this is my Ethernet address. So this is the Ethernet address of host, this is the Ethernet address of destination. So all it wants is that corresponding to this one, destination address, IP address, what is the Ethernet address? This simply this query this will have, right? So okay, source will have. All right, so now what will it do? So now simple thing is that every machine, like your machine, will have at least this, a table, it's called ARP table, which will have IP address, MAC address, and time to live or lifetime of this mapping, right? So it's already there. If this mapping is there in your laptop, for example, okay, then it will know the corresponding Ethernet address, okay, of domain name server. If that's not, then it has to do some query. All right, if it's not in the internal table, then it will broadcast, sender will broadcast who has IP address 1.2.3.156. Okay, so this is, for this we want to know, this is corresponding to this one, we want to know what is the this Ethernet address. Okay, all right, the receiver, this one, the one, the domain name server responds or broadcasts it, right? Note that both are broadcasts, that my MAC address is this one, so use this. Okay, and then sender caches it or puts it in, writes it in its ARP table. All right, now what happens that when all other machines receive this message, they also change their ARP table. Now this whole mechanism is based on the trust. Now tell me where this can be misused. Anyone? You apply same logic that we have
Hacker
done
may
in case
possess
of,
someone else's IP address.
yes, very good. Now you can do number of attacks here. Okay, because there is whenever there is a broadcast and trust, there is opportunity for attacker. Okay, so anybody can respond now. Once they see ARP request, then why not a rogue element or attacker respond back? Respond back with what? IP address is, see, A is asking, IP address is giving IP address of B and asking that give me Ethernet address of B. This is, this A wants. Okay, now a rogue element will respond back with IP address of B and corresponding some Ethernet address of his choice. It can be wrong. It has to be, if he wants to manipulate, it has to be something which will create some harm. Now, what is the possibility? If we want to do denial of service attack, it will respond with Ethernet address which is non-existent in the network. Some 48 bits, random 48 bits. It will cause denial of service attack, right? What could be other malicious thing it can do? Can it do man in the middle attack? what happens? It responds back with its own Ethernet address. Okay, these are the possibilities, right? So let's look at the first one, which is denial of service attack, right? That we have already discussed. It replies, Alice makes a request for ARP of Bob. Alice wants to communicate with Bob, and instead of Bob will respond, of course, later, but Trudy in between responds back with IP address of Bob and hardware address of some non-existent Ethernet. Okay, so this causes denial of service. Second thing is that, okay, now here Alice wants to know MAC address of default router. Okay, because DHCP request has given default router's IP address, but and this all part of one net. Okay, local area network. But Alice wants to know what is the Ethernet address of default router. Okay, through which she can communicate to external world. But what will happen? So now when she sends this request, instead the default router anyway will respond, but 2D also responds with IP address of default router and hardware address of itself. Okay, now Alice receives this and thinks that the hardware address of 2D or Ethernet address of default router is something that corresponds to 2D. Okay, so now what will she do? All the message she wants to send to external world, say for Google or some other server, she will wrap IP packet in Ethernet and send right here the Ethernet address of 2D, thinking that this address corresponds to default router. So all the messages now will come to 2D. Okay, all right. Now 2D can manipulate this. Okay, now we can also do man in the middle attack, right? So Alice wants to communicate with Bob. So okay, Alice knows Bob's IP address, but not Ethernet address. But 2D responds with his own Bob's IP address, but his own Ethernet address or hardware address, right? So now what will happen? Okay, now when Alice sends a message, I say whatever message in IP protocol, okay, wraps it over Ethernet and writes here the Ethernet address of 2D. 2D coolly receives it, opens it, manipulates the message, and then sends it to Bob. Can it send it to Bob? If it knows if already knows the IP address of Bob and also knows the IP address of Ethernet address of Bob, and it can then simply send. This is the first thing that Alice sends a message using 2D's hardware address. 2D receives it, and the next is that 2D manipulates the message and uses the IP address of Bob and hardware address of Bob. For that, 2D has to know hardware address of Bob or Ethernet address of Bob, which is very simple. Okay, so this way we can do man in the middle attack. All right, there are a lot of countermeasures. Okay, first thing is that this table can be static. Okay, now there's a possibility of static table, right? When this table can be static? When there is no new user is allowed to come inside the net. All right, or within data center number of machines are fixed and you're not going to change it, then you can create this kind of. But if there is environment or lab or somewhere people keep come in and go, or a conference center where people keep coming and going, then you cannot have this kind of static address table, right? Or for example, your library allows people to connect, then you cannot have this kind of, because every day a new person will come. Okay. Second is that how can we ignore unsolicited mapping, unsolicited responses? 2D has responded back. How can we make machine intelligent enough to avoid this, to know that this unsolicited or spurious response is coming? Yes, we can do that, right? I mean, we can make machines more intelligent. Okay, and then we can monitor ARP poisoning packets. It's again by making machine more intelligent and observe what's happening, and then he knows that possibly will come to know that there is a 2D kind of person in the net, right? Because it's responding differently for different kind of requests. Okay, and then there are port security mechanisms like disconnect port that attempts ARP poisoning and so on and so forth, right? And also restrict the broadcast domain. If the broadcast domain is small, then there won't be a problem like this, right? So basically, instead of switches, one can use routers. Okay, all right. Any question? So what we have covered so far? We have covered DHCP attacks, we have covered ARP attacks. These are layer 2 attacks, right? What else we can do? MAC address spoofing is a simple thing. This is very simplest thing, right? One can do. Can you stop me sending spurious mail to anybody? I write a letter, put it, some person's address, and put somebody's source address, and just send it, right? Can anybody send bomb to you packed in a parcel? Can it? Of course, yes. Does this postal system allow? Yes, I mean, postal system will not know if the bomb size is micro size, maybe just few grams, and wrapped well, and somebody writes your address, and sender's address could be anybody, and it will be delivered to you. Okay, all right. So now can we apply this? Any user or any machine can send Ethernet it can create Ethernet packet, can write anybody's destination address or anybody's Ethernet address and anybody's source address and send it. What will happen? Nothing. Nobody will find it out, right? Okay. All right. So this is the method. Okay. So it's like this. Okay. So now it can also be done to do other things, like for example, look at 3 machines A, B, and C. Okay. So in the beginning, this is the table. The table that this switch creates is this one. Okay. Now what is the next thing? Now this is self-learning switch, right? So this will work beautifully. Everything. Now this is ROG element. C is ROG element. Now it will create a message, Ethernet message, and writes is okay. Okay. So basically it okay, it goes like this. Okay, so what happens is that all right, now A is interested in knowing what's happening between A and B. I'm just trying to visualize it this way, right? So C wants to get messages that are being sent from A, maybe to B or whatever, right? So what it can do is that it can use IP address, MAC address of A. It will send a message to switch, which will Ethernet message with and identify our source address is Ethernet address of A. Okay, so what will happen now? Okay, so now this switch will change the mapping that switch port 3, this one has two MAC addresses associated, A and C. Okay, now when Bob sends message to Alice, it will be sent here to C. All right, so this is called simple MAC address spoofing. Just create a Ethernet packet and then send it to switch, okay, up to anybody, and switch will learn from that Ethernet address, the wrong Ethernet which is in the packet is connected to that particular MAC address connected to a port. So A's MAC address is now considered to be connected to port 3. So when B is communicating to A, all this will come to C. All right. So that's all about today's lecture. Something that I want you to learn is VLAN. We may not have time to go through VLAN, but in general for 2 minutes I will try to give a basic concept. Now what happens is that whole institute, your institute, where Comp Science Department, EE and MAC are connected to a single switch. What's the problem here? And then switch is connected to a router. What is the problem? And this forms the IP subnet. All this will have one IP address, single IP address, and of course you can create IP subnet. So inside that each machine can be given other IP address, right? Okay. So what's the issue here? Quickly. Anyone?
Sir, if the switch fails, the network goes down.
Very good. So this is single point of failure, of course. This single point of failure. The other issue is that this broadcast domain, Ethernet works on broadcast. When it doesn't know destination address, where destination is connected, when A is communicating to Z here, and A doesn't know Ethernet address of Z, this switch, okay, A knows Ethernet address of Z, the switch doesn't know where Z is connected. It will send it everywhere. And from this learning will start happening, right? When Z responds, all switches on the way will know about it, but there is a broadcast. So now this if there are 10,000 machines in this, then there is huge amount of bandwidth is wasted in broadcast. So we need to restrict the broadcast. And now what we can do is that we can create these small subnets. And in order to do that, we can have routers in here, right? So we can have, each department can have a router. Okay, that way we can create subnets. Okay, this first thing. Okay, but what is the other problem? User management is big thing, a big difficulty, right? Now if you create, now each switch that you let a buy, you will buy for, let's assume 10024 ports. Only few, and you have just 200 students in the department. Remaining ports will be wasted, right? So that's inefficient use of switches. And secondly, managing users. Now, when you are CS student, you may also go to EE to do some job. Okay, and then while your identity remains with ComSci department, you should also be able to connect from EE department. Okay, so statically you cannot define this, right? It means now in this switch, I can say that there can be some students of EE department, some can be of electrical engineering department. So now I can buy a big switch. Okay, so first solution is that I can buy a big switch and say that I will internally partition this in two switches. Okay, there's a CS department and EE department. So this is one way, right? And anybody who broadcast, this Ethernet broadcast will limited to this one. Similarly, the broadcast will limited to other one. Now this kind of thing we can do using virtual LANs. We can split a switch into multiple switches. That's first thing. Okay. Second thing is that, now this, and in order to do that, we will have some kind of internal routing mechanisms, right? Okay, all right. And we can also do one thing that, the different departments will have different this kind of switches, and we can, within that switch, we can say you belong to EE department. Like CS department will have switch. Okay, the red colors correspond. Some ports can be defined to electrical engineering department. Similarly, EE is EE department. These are the machines that correspond to EE department, but some students can be given access here, but their traffic, when they send a packet, right, Ethernet, it do some kind of ARP, etc. All this will go to all these red machines. The traffic distribution or traffic movement will happen within the department. All the physical locations of the switches could be very different, right? So basically on physical switches you can create virtual networks. So this is the concept. All right, so I would like you to go through VLAN, because VLAN provides some kind of security, and most of switches that we use today are VLAN switches. All right, thank you. Any question?